Assalamualaikum. Welcome to World School of Bangladesh. Today we'll study chapter 1 of Mathematics of class 6. Have you ever wondered how the number came from? How we count things and other stuff? So today we'll know about the story of numbers. So first people used to count things using tally marks. How tally marks used to work? Here we can see that one line, two line, three line, there are many lines. So one line represents one, two line represents two, three line represents three, and when it becomes four line, then to represent five we used to cross the four like this. Suppose I have one pen, then I have been gifted 3 more pens, then I have total now 4 pens, then I bought another pen, so I have total 5. So that's how we represent 5. Suppose now I have been given another pen from my friend, so I have another pen, so this represents 6. 1 2 3 4 5 6. So to represent 10 we'll use 1 2 3 4 5 6 7 8 9 10 11. That's how it's working. So now let's go to another system, counting with rope knots. So there are different methods they use to count things. Here if we zoom here, we'll see that here is overhand knot. So there is 2 knots. So 2 knot represents 2, 4 knot represents 4, 6 knot represents 6, and to represent 1 we use double knot. Here we can see that it's zoom version, figure of 8 knot. This kind of knot represents 1, and every other single represents, like if there is 2 single knots, this kind of knot, if there is 2 knots then it's 2, if it is 4 knots it's 4. Now here we can see that this rope represents a whole number of 2461, means here the least number, here the end point of the rope has 1, then 6, then 4, 2. So serial by we wrote that 1 6 4 2. And if there is a long knot like this, then it represents 7. And let's go to our tally. So here you can see that to represent 1 we use 1 line, to represent 2 we use 2 line, to represent 3 we use 3 line, to represent 4 we use 4 line, and to represent 5 we use this like 4, that costs 5. That's how we represent everything. So now we can tell easily what's this represent. So here we need to find out what this tally represents. So as we already have seen, this mark represents 5. So 5, another 5, it becomes 10. 10 plus 5, 15. 15 plus 5, 20. 20 plus 5, 25. So the answer will be 25. 25. Our next is 27. How you represent 27 in tally? So as we have already seen, to represent 5, 10, 15, 20, 25. Now if we add another 2 more, it becomes 27. Next, understanding time on the clock. So how we understand time by watching a clock. Clocks are 2 kinds of digital and analog. Today we'll learn about analog clock. So in clock there were 3 hands of clock. One represents hour, one represents minutes, one represents second. The represents second. So here we can see that here this is the smallest one. So this represents hour. So it is in 3. So it is 3 point, and it is in 11 something. So like it's between 11 and 12. So when it's 11 and 12, like every represents a 5-minute gap. So we will see that it's 3, then it is on 11. So when it is on 11 into 5 equals to 55. And here we can see that it's not actually in 11. After 11 it have gone another another point or another line. So this small lines represent 1 minute, and this big or bold lines represent 5 minutes. So here it represents 1 minute. So 55 plus 1, 56 minutes. So it will be 3:56 o'clock. Similarly, if now second, how seconds? It is 1, 2, 3, 4, 5, 6, 7. 7. So 7 into 5s are 35. So 35 seconds. So 3 hour 56 minute 35 seconds. So why we are multiplying 5 every time we're counting here? Because look here, every smaller lines represent 1 minute or 1 second. When we'll be using this hand, then it represents 1 minute, and when this will be counting for this, it will represent 1 second for each smaller line. So after every 5 seconds there is a bold line. So we will just count the bold lines, then multiply the bold lines with 5, then we will get our minute or second. Next, okay, now we're trying to do you know how the Mayans used to express numbers? So here is a table from where we can see that how Mayans used to express numbers. Mayan used this kind of symbol for 0, and for 1 there was 1 dot, for 2 2 dot. So obviously for 3 there will be 3 dot, right? For 4 4 dot, and for 5 they used a straight line. So for 6 they used 5 and 1 dot, that means 6. For 7 it becomes straight line and 2 dots. So obviously for 8 it will become a straight line and 3 dots. And for 10 it becomes 2 straight line, because 5 plus 5 equals to 10. So to represent 10 they use 2 5. So obviously it becomes 10. So to represent 14, what will be the symbol? To represent 14 we can use 2 straight line, which is 10, and we need another 4 to be 14. So we can use this become 14. It's not so hard, see? So how will represent 19? So to represent 19 we can use 3 straight line, then it become 15, right? So to become 19 we need another 4 dots, so it will become like this. Okay, so the story of decimal number. Next topic is the story of decimal number system. So mathematician Aryabhatta, pronounced as Aryabhatta, who used to live in Indian subcontinent, introduced a method of numbering system, which is called decimal number system, where we use these symbols to represent from 1 to 9. This is for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happened after 9? How we count after 9? So instead of using different symbol, we will use these 10 symbols to represent 10, 11 and other numbers. So what was our first number which has a value? Like 0 has like 0. When we have nothing, we call 0. But when we have a one thing, then it becomes 1. So to represent 1, we use 1, 0. So to represent 11, we will use 1, 1. To represent 12, we will use 1, 2. This way, we will use the first symbol 1, then the other symbols behind 1 to represent different numbers. So what happened? We use every number because like it becomes 99. After 99, what happens? So after 99, we use 100. That's mean 1 was in the second place. Now it goes to the third place, and there is 20 behind 1. So after 100, we write 101, 102. This way this continues and becomes 199. And after that, 1 is replaced by 2 and 9 is replaced by 00. So 200, and then again it becomes 201, 202, dot dot dot. So this 10 signs we used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 10 signs or symbols. These are called onko in Bengali and digit in English. So we will see how this digit used to represent various numbers. So Aryabharta used from right to left to name them one, tens and hundreds. From right, the first place will be called ones, the second place will be called tens, and the third place will be called hundreds. So how it works? So 120 tens plus 30 ones equal to 123. That's mean if we have 252 taka, that's mean it's actually 200 plus 50 plus 2 taka. That's mean what happening? 100 have a 3 digit and 50 is 2 digit. So 50 is actually 5 tenths. When 10 fives are added, then we get 50, right? So that's it's called 5 tenths, and it calls 2 hundreds, like, right? Like if we add 2 100, then we get 200. So it becomes 2 hundreds, 5 tenths plus 2 ones. Like if we add 2 1, then it becomes 2. So that's how we represent our numbers, or we write our numbers. Now we will see our local system to represent numbers. So how we will represent 1,30,82,524. Here we have ones, tens, hundreds, thousands divided into thousands and tens of thousands, and lakhs are divided into lakh and millions, and then 1 crore. So here it is 24. So 4 is in 120, so it is in tens. 500, so obviously 5 will be in the third place, which is 100. 20,000, so 2000s, 82,000. That means first 2 then 8. So 2 will be on the 4th position and 8 will be on the 5th position. Then lakhs. Here we can see that it's written 1 crore 30 lakh, 30 like 30. So in our lakh plus or 6th place it will be 0, and in the 7th place it will be 3. In the Bangla we call it nijut, in English we call it millions. And after that 1 crore. So after 10 lakhs place or nijut place we get 1 crore place. So if we are asked to write 5,000, then we will read 5,000. So first we have 0, 0, 0, 5,000 because it is 1 place, it's 10 place, and it's 1,000 place and it's 10,000 place, so it is 50,000. So here we wrote 50,000. Sorry, my bad. Here we have written 5,000 is 1 place, it's 10 place, it's 100 place, it's 1,000 place. So we have written 5,000. If we have asked written 50,000, then this means 50, 50 and then 1,000. So here there is 0 in our 4th place. But if you are asked written 55,000, then it will be like this: 1, 10, 100, 1,000, 10,000. Now let's see our international system. In international system we use ones, tens, hundreds, thousands, but see here we are using 3 position for thousands, whereas in our local system we use 2 position for thousand. Then for millions we are using 3 position, for billions we are using 3 positions. So if we are asked to write 244 billion, 244 billion, 230 million, 80,524. So 24. So 1 place 4, in 10 place 2. Then 500. So in the 3rd place it will be 5. Till now it is similar like our local system, but after that it has written 13,080,000. 30,080,000. So 80,000. We have to write 80,000. So 80. I guess they have done a mistake. Here it is 80,000, but they have write 82,000. So probably here it should be written 82, or there should be 0. So suppose we are taken as 80,000, so it will be 8, 0 in 4th position, 0 in 5th position, 8. And they asked 13 million. So 13 million. So from million position we'll go from this position 3, 1, 13 million. And here it says 244 billion. So 244 billion and 230 million. So 230 million, 230 million. So 213, 230 million. And it's 244 billion. So 244 billion. So they use 100 inside of millions and inside of billions as well. They also can use hundreds in thousand places. So they can also have written like 182,000. Then in place of 0, here it would have been 1. So see, if we compare our local system with the international system, we can see that till hundreds everything is same. After that, our thousands and their thousands don't actually match. Their positions have gone up to 12th position, but our system has still 8th position. Okay, there's a work. It's written in each pair. Make a total of 16 pieces of paper by writing 1, 0, 2, 9. So from 1 to 9 digits with repetition. A symbol is given here. Okay. Now each of the numbers of the pair has to take 8 pieces of paper through lottery when 16 pieces of made are. So here we have a little game. Basically in this game it has to be played in group. So suppose you are playing 2 people, so you will write 0 to 8 in a piece of papers, then you will fold them, then you randomly pick them, and one will say number. Who will get the highest number will get 1 point, and who will get the lowest number or digit will get the 0 point. That's basically for to know the order of the digits. Okay, now we go our exercise. Here it is written, without any repetition, from the highest possible number the smallest possible number of 4 digits using the digits given below. So basically they have asked us to write highest possible number and lowest possible number using 4 digits from here. So here it is given 2874. 2874. 2874. So we have to write the highest number. So we have to prioritize the highest value digit. So for here the highest value digit is 8. So as we already know that from right to left the value increases. In right, the first place for 1, the second place is for tens, the third place is for 100, and the fourth place is for 1000. So for the biggest number we need to write the highest value digit on the 1000 position or the first position. So here 8, we first write 8, then 7, then 4, then 2. So it becomes the largest or biggest number. And to write the smallest, we will reverse the technique. We will write the smallest number first. So 2, 4, 7, 8. It is the smallest number possible with this 4 digit. So the rest 4 of them will be done by you. Okay, let's go to the second. Form the highest and the smallest number using any of the digits twice. So here at first exercise we are asked not to repeat letters, but in the second we are asked to find the highest and lowest number using any of the digits twice. Using any of the digits twice. That means we can use any one digit twice, not every digit. So let's do the 8. So 2 is 387. 387. So 387. Again we'll follow the same thing. The highest value digit is 8. So we'll write 8. Now we will repeat the highest value digit twice, because now we are trying to find out the highest value number. So 8, then after 8 is 7 and 3. So this becomes the from low value to high value. So it becomes the smallest. So suppose if I would have written 3, 7, 3, then it wouldn't have been the smallest number, right? Because as we can see in the 100 place there is 7, there is 3. So when comparing numbers, we'll first see the highest position. Like if it is a 4-digit number, so we'll see the 100 place or the 4th place. Who have the highest value in the 4th place will be higher. If they have the same value in the 4th place, like this, they both have 3 in the 4th place. So we'll go to the next place, which is the 100 place. So in the 100 place, it has 7 and it has 3. Which is bigger? Obviously 7. So this number is greater than this number. So this number is greater than 3, 3, 7, 8. And this is the largest number because obviously the highest number is on the highest value. It is on 1000 place, it is on 100 place, then it's on 10 plus 7. In one place there is 3. Rest 3 of them will be done by you. From the highest and smallest possible numbers by using 4 different digits given below and by fulfilling all the terms started below. Okay. Here we asked to form here we asked to use 4 different digits to make a 4-digit number. But we are given a condition. Suppose here we are given a condition that digit 7 has to be in the place of 1. So digit 7 has to be in the place of 1. So in the place of 1 we have written 7. After that we can use any digit to form the largest and smallest number. So when we are forming the largest number, we will focusing on the largest value. So as we have already used 7 in the one place, we can't use 7 again. So after 7, like from 1 to 9, what is the highest number? 9 obviously. So 9 will be in the this position, on the 1000 position. And after 9, what is the largest number digit? 8. So after 9 we are writing 8. Then after 8 the highest digit is 7. But as we have already written 7 in the one place, we are written the next largest number, which is 6 here. So in case of a smallest, we will find the smallest number first. So from 0 to 9 the smallest number is 0, but we can't write 0 in the 1000 position, because if we write 0 in the 1000 position, then it is not a 4-digit number anymore. It becomes a 3-digit number. That's mean whenever we write 300, this 0 has no value. Whenever 0 is written in front of any digit, it does not signify anything. But if we write 0 after any digit, it becomes 30. Another 0, it becomes 300. But if we write 1, 2, 3 or 5, 0 or 4, 0, doesn't matter. It still remains 3. 3 remains 3. So same way, if we would have written 0 in this position, the number would have become 3-digit number. So we don't want that. We want 4-digit number. So after 0 the smallest number is 1. So we have written 1. Then 0. Now we can write 0 in the next height position, which is 100 position. So 1, 0, then we have already used 1 and 0. So the next smallest number is 2. So 1, 0, 2, and already in 7 position, in the 1's position, it is 7. Okay. So what? Let's see the next example. So in the next example, our condition is that digit 4 has to be in the place of 10. So let's see, let me clean this. Okay. So we have 4 in the 100 position. Now we have to find out the largest number. So again, for largest number, the largest digit will be here, then the second largest digit will be here. So after 8, the second largest is 7, so it will be here. And to find the smallest, here 4 will be here, right? But the smallest digit is 0, but we can't write 0, so 1. Then again 0, then after it's 2. So it is the smallest, it is the highest. I think you guys have understood already. So let's go to next exercise. So here we have given a puzzle we need to solve. Suppose you are given a birthday present, but the box is locked, and to open the box you need to solve the puzzle. The lock has a 3-digit number. So the puzzle here we are given, if we solve this, we will get the value of the lock. So the first one is written that one digit is correct, but the digit is in right place. That's mean among this 3 digit, one digit is right. Right means like one digit belongs to our lock number, but and the place it is in is right. Like if it is suppose if it is 8, then the in lock it will also be in the 10th place, but we still don't know which one of them are right. So let's go to the next condition. One digit is correct, but the digit is in wrong position. Say here we have they have written that one digit is correct among these 3, but the position it is in is wrong. So look here, if we compare these two conditions, here one digit is correct and it is in right position, and here one digit is correct but it is in wrong position. So look, the 6 is common in both places and the position of 6 is same, but here it is written that it is in wrong place, and here it is written one digit is correct and it is in right place. So that means 6 is not our answer. So 6 is not our answer. It is eliminated from our option because it's contradict each other. Here only one can be right and it is in right position, and here only one is right but it is in wrong position. That means 6 is not our answer and 6 is not in 100 position. In our third puzzle, there say 2 digits are correct but the digits are in wrong place. That means among these 2 digits are correct but they are in wrong position. So it has to be between 2 and 0 because 6 is not in our option. Okay, so 2 and 0, but we don't know the position of these 2, like where they belong. So now let's go to our third. None of the digits are correct. So none of the digits correct means what? 3, 7, 8 are not our option. 3, 7, 8 are not our options. Then the last puzzle said one digit is correct but the digit is in wrong positions. They said one digit is correct but it is in wrong position. As we already know that 7 and 8 is not our answer, so that means 0 is our answer because we have already eliminated 7 and 8 from our option. So 0 is our answer, but the digit is in wrong place. That means 0 cannot be in the one place. Digit has to be in the 10 place, because if 10 place or 100 place, we are still not sure in what place it is. Suppose. Okay. So it cannot be in this place because it is in this place, but it is saying it is in wrong place. That means 0 is our among the 3 digits, but it is not in one place. It has to be in the 100 place or in the 10 place. So our another answer was 2 and 0. 6 is not our answer. Okay, look here, 2 digits are correct, but digits are in wrong place. That's mean here it is written 2 digits are correct, so we already know that 2 and 0 are correct, but they are in wrong place. That means 0 would be in the 100 position, because here is 0 in 10 position. It also written that it is in wrong place. Here it is in 1 position, it is also written in the wrong place. So 0 has to be in the 100 position. Now remains 2, where 2 will be. So but let's first focus on the first. Here it is 1 digit is correct and the digit is in the right place. So we already found that 2 is our right digit, and if it is in right place, that means it has to be in the 1 place. So it will be 1 here. 2 will be in 1's place. So, and here it is written 1 digit is correct, but the digit is in wrong place. So among this, 1 digit is correct but is in wrong place. So it cannot be 1, because if it is 1, then it would be in wrong place, but we need something which would be put on the 10 place, and it is already in 10 place. So 1 cannot be our answer. 6 cannot be our answer because we already eliminated 6 long before. So 4 has to be our answer, and 4 is in wrong place. So 4 will be in the 10th place. So our log number is 042.